Okay, now it's time to continue on from the last video about the password scraper. I tried it on different systems, freaked out because it wasn't working, didn't know what was going on. I'm an idiot. I'm a total idiot, and I rewrote it. What I ended up doing was downloading a script from the shop and seeing what the heck, this password is doing files where we were doing computers. So, and I'm like, what, these results are confusing. And it turns out, well, we'll go through. So I got some IP specific here as a demonstration of the new code. So as far as the code goes, everything above this line, well, except for access password and get password, all of this up here is standard. Get password and access password, I haven't made them work just as one right now, because both the file version of getting passwords and the computer version of getting passwords requires completely separate code, just because of the way it's returned. So we grab our typical params, do our net session, have the dump from metalib. Some of this don't matter. This is all future stuff for me, because I'm gonna, right now, if it finds it, it processes it and then moves on until its end, until it's over. And I don't like that. I want them as objects, or these are maps. I want them, with map is an array essentially. I want them as an array so I can choose what to do at the end of a run. Therefore, because every time this runs, it's going to put items in the system's log. So enough of that out of the way. This first one, holy Lord, I haven't even started drinking. My programmy, my program. Let's try that. Luckily, it's all up and down arrow from here. So this is going to be a live SSH version 1.0. It's pointing out there's a shell here. I haven't even looked into the shells yet. Right here we got a file. So everything in here is pretty much the same about doing the meta exploit to get the results. We're just mucking with the results. So if type object equals null, then not equal to null, because you'll notice these don't have any objects in between them. That's because it returned null for the type of object for whatever reason. But if type object equals file, which it does here, then file equals results get files. So what'd you get? For file in files, print, this just makes it go white, file.name. So there were three files here. So it went through 3 times and printed those 3 files that this exploit up here found. This exploit came as a result here as a type object of file. So type object equals type of result. And it turned into this type object does equal file, where you notice this type object down here equals computer. So not file. And then it continues on. This is why these two are completely different in coding, because of so if we used this coding, which doesn't work, I've already tried, it flat out won't work. If we immediately tried to just say not find out if it came from the folder that started with the path of etc., then we just grabbed the file and ran it. This is a Linux thing. That's what we'd get. That's not what we're looking for. I don't even know what that does. So we have to put these checks in. So even though this file found password, is it the correct password? So we go in for file and files because we still don't really know which file it is. I haven't figured out how to separate these, but this code was the most efficient I could make it. If result is folder and result dot path equals etc., then if file name equals password, that's where we're separating this password file out, then print color white found. These were green before, but yeah, so it's printing found password. So print found plus file dot name, so found password. If file then has the permissions of read, then well, right here we don't have read permissions, so none of this gets processed here. It doesn't print has read permissions. It doesn't access the password file. We're screwed. We can't get the passwords with this particular file because we don't have read permissions for it. So then we go to port 80. Perhaps. There you go. You're such a good little program you ran. Here we got something completely different out of our file. So let's go up here first. Whoop, there's more file. And that's where we ran it. So in this case, we didn't get anything out of computer or file for passwords, but we did reach a file that gave us everything in the user bin directory. That could be useful to program somewhere in here. You would just have to, like right here, we went specifically for a typical, the file that we wanted. This is programmed for that file if the result is file. So you would have to do that for something like this. Now we also picked up, and off of this overflow, this other overflow right here, created this. Don't know what that file is. Because that file, this file right here didn't return files or something. I don't know. That is something I'm going to have to look into. All of these is something I'm going to have to look into. Where was I? Yeah, this other file down here that it caught, this is the bin directory. So you could access the bin directory using this right here. You have to code for it, but you could access it. I've never really looked in the bin directory, so I haven't seen if employees viewer is there. There's another hack I'm looking at. I've been trying to find this employees viewer. Well, maybe they're always in the bin. No wonder I couldn't find them. Okay, anyways, so there's different versions of the file, of the result of file. So that was 80, so we're going to go to 14.1.1.1 and port 22. I said I wasn't going to do that, but I did it. I did it like a dirty little boy. 22. Now this is a different version of SSH. The other one I believe was 1.0. This is 1.02. And right here, we found file. That's the type we were looking specifically for this code. Password was there. It was in path of etc. Folder of etc. It was readable. Don't know. So it came down here. I did print result path here, which is etc. Accessing, then this is going up to the decoding strip, which is just in this case, it's just giving you the what was there in password, which is root and harja. You kind of have to copy and decipher it yourself. It also gave us, with this, access to the bin files. Again, access to... Really? Yeah. Gave us access to user bin file again. So that's file. But that's everything you can glean off of just this code right here. You can make more code to take advantage of this stuff. Alright, what the hell did I type? Alright, we want... Nothing else was there. We gonna go now to 25.12.1.1. 25. Now, these IPs are arbitrary. They only apply to my single player game because when you create a single player game, you create a procedural based world, but the results will be the same in a different world. It just won't be at the same IPs or ports. Well, it might be at the same ports. Should probably be at the same ports. What are you talking about? What did I spell wrong? Figures. So this is SMTP version 1.04. Right here, our computer code down here got caught. Notice it's actually deciphering because it has a different program up top. So this one is calling, well, this one's calling access password file. So the fast one, but didn't decode the files, was access password file. This is the one that did decode the file. So this was the function coming from the computer, and this was the function coming off the file. Yeah, it's sloppy and messy and disgusting, but yeah, whatever. So the reason the code's different between this and this is because the type object of computer was the result of etc. password. And so it's simple. If result and file has permission. It's just, I'm like, wait, why if result? Don't know. Again, I took this code off of a shop script and then shrunk it down, sort of. So it's if result and file has permission. Why did I do that? I don't know. It still freaking works all the time. So so it's readable. Then print, yay, got password. And then it lists the users. So it creates another array. So list users equals file get content for every line in the array of list users. User pass equals, yeah. This is still essentially the original code from last time we talked about this, that last episode. However, it's been beefed up a little bit. I have gotten... Yeah, there's nothing else here. Wow, there's like one computer. That's it. Oof. And there's only one user, too. Social engineering would be interesting on this one. What else has this got? I didn't really check because I'm so thorough. And it's got an 80. I think we've already done that. Okay, so we got that says port 25. Oh, it's stuck. Yeah, this is the downfall of I got something wrong in here. Where for this one, no. I didn't get something wrong. This is kind of why I want to not do this just on the fly, because we reached, so file 07. Okay, where did this nightmare start? Alright, we started here. This address, that value equaled computer, which equaled what we needed down here, so it went ahead and grabbed the passwords and deciphered them. Then it continued under the same value, yet a different value, same address under a different value. It also found file. No, we don't. Okay, past this one. So that file did nothing. However, okay, it changed its. Supposed to be a line here if it changes its address. Oh, that's a different program. So it changed its address, it changed its value, and also had this etc. password in its file, its result file. So it went ahead and because it deciphered the same passwords. Under the exact same address, it found this value, which led to the exact same result. So it deciphered the passwords again. And then we're finally done. So what you're seeing here, now notice, what are this? What is computer? What is shell? What is file? File. Get contents, get files, get folders. If result has permission, if result and file has permission, if result, file, etc. password, this is the one I don't quite get. That would be folder, but it's returns a string with the name of the file. I don't know. Anyways, these are up here. So we'll go to computer. We used has permission. Is that on here? Oh, file. No, that's file. We're still computer file. Returns the file located at the given path. File equals get shell host computer dot file. Instead, we're doing this. We're not doing it locally. We're doing it remotely. So we're not on shell host computer. List users file. I'm getting so confused. There we are. Result equals file, etc. password. So if you were doing this locally on a shell, I guess you might use this. I don't freaking know. But sometimes there's useful code in this. Usually there's not. But this is everything about computer. So you can pick and choose what you want to test for, like, well, we know what that computer is. We know what that computer is. We don't know what that file is. So what could that file be? Could it be a change mod? Could it be copy? Could it be delete? It could be a lot of these things. So we would have to query that to figure out what it is and figure out, like, it's a type of file, but what type of file? What does it want to do? So this is just an update to the last video, and this is some of the amazing stuff I've figured out so far. Hope this is helpful. It's confusing as snot, I understand. Object-oriented programming, ever since I first tried it, way back in Win 95 or Win 3.1 days, it put me over a barrel and screwed me in the butt. And it's been doing that ever since, because it makes no sense in my head how all this crap works. I hope it does in yours. Everybody have a great day.